Hello everyone. So for today's discussion, we are going to learn how to solve problems involving reflection, refraction, dispersion, and polarization in contexts such as, but not limited to polarizing sunglasses, atmospheric halos, and rainbows. So first, reflection. Reflection is a natural phenomenon of bouncing back off when it falls on smooth surface, let's say mirror. Law of reflection. The law of reflection states that the angle of incidence is equal to the angle of reflection. So let's say if the angle of incidence is 30 degree, automatic na ang angle ka reflection is 30 degree. Example, consider two plane mirrors, mirror 1 and mirror 2, arranged perpendicular to one another. An incident light ray strikes the first mirror at its middle point 20 cm from its intersection. At what angle or incidence should the first ray be set to produce a reflected ray that will hit the middle point of the second mirror? So, amo dya ang diagram. So, the solution given is mirror 1 is equals to 40 cm, mirror 2 is 30 cm. Ang ginasagap is angle of incidence. So, process. Things to consider. The angle of incidence or theta I is equal to the angle of reflection, theta R, law of reflection. The length consider are all half of both mirrors' lengths. So, ang mirror 1 and mirror 2 should be 1/2 length na. Tapos, the angle beta could be the K in determining the angle of reflection since when combined, the angle may sum up to 90 degree. Fourth, when the angle of reflection is determined, the angle of incidence will be the same. Extracting the available information from the problem, you can employ a trigonometric function to determine beta using the formula of tangent. This is the formula. Tangent beta is equals to 15 cm, which is the mirror 2, divide sa 20 cm, which is the mirror 1. It equals to, tangent beta equals to 0.75. Beta, it equals to tangent raised to negative 1, 0.75 is equals to 36.87. To determine the angle of reflection, i-minus natin ang 36.87 degrees sa 90 degree, which is equal to 53.13 degree. Using the law of reflection, which is ang angle of incidence is equal to angle of reflection. So, ang answer is 53.13 degree. Automatic, ang angle of incident is equal to 53.13 degree. Next. Refraction. Snell's law. Refraction occurs when light passes from one medium to another and changes speed, which cause a change in direction. So, ang refraction is ga-change na naka-speed and ga-change man tana sa direction. Sample problem. A light ray coming from air penetrates an unknown material at an angle of incidence equal to 55 degrees with respect to the normal. The light has a refractive index of 1.0 and the unknown materials causes the light ray to bend at 45 degrees with the normal. How fast will the light move on these materials? So, amo yung diagram. Tapos, solution. Given is angle of incidence is equal to 55 degree. Angle of reflection is equals to 45 degree. Tapos, ang normal air is 1.0. So, ang ginasagap natin is speed of light kag ang unknown medium. So, process is determine the end of the unknown material using Snell's law of refraction. So, amoy ra ang formula. N1 sine theta 1 is equals to N2 sine theta 2. Where N1 is our normal air, sine theta I, it equals to, ang N2 natin is ang ating unknown material. So therefore, N unknown material is equals to normal air times to sine theta angle of incidence is equals A over sine angle of refraction. It equals to 1.0 times sa sine 55 divided by sa sine 45 is equals to 1.16. So, para mabuo natin ng speed of light, ang formula kara is V is equals C over M, which is ang 3 times 10 raised to 8 meter per second is value rin na nakasira. Tapos, ang N natin is 1.16. Ang more na ang unknown material natin. So, divide lang sa dalawa, it's equals to 2.56 times 10 raised to 8 meter per second. So, pangatlo is there's dispersion. Dispersion is the spreading out of polychromatic into its different wavelength. This due to the fact that different wavelength of light travel through given materials at different rates. So, ang dispersion tanang nga is the spreading out kang different color. Let's say red, ang color ka rainbow, like that. So, sample problem is a light ray hits a glass at an incident angle of 55 degrees with reference to the normal in the air. Two different glass were observed that caused the bending of light at different angle. The red color light makes angle of 28.5 degrees, while the violet makes an angle of 26.5 degrees with reference to the normal of the glass. What are the index of refraction of these glasses for different color of light? What are the speed of two colors as they pass through this medium? So, ang solution, ang given, angle of incidence is equals to 55 degree. Angle of reflection, 28.5 degree, ana ka red. Angle of reflection, pagid is 26.5 degree, ana ka violet. So, ang ginasagap is ang normal glass, kang both color, kag speed nanda. So, ang gamitin natin kaya is ana ni Snell's law of refraction. Amo yung solving. Done. Normal glass for red is equals to normal kang air times sine angle of incident divide sine angle of reflection. So, it equals to 1.0 times sa sine 55 divide sa sine 28.5, it equals to 1.75. Amurang normal glass kang red. So, for the violet is same man gyapon ta nga process. Normal glass, it equals to normal kang air times sa sine angle of incidence kag divide sa sine angle of reflection. It equals to 1.0 times sine 55 divide sine 26.5, it's equals to 1.84. So, 1.84 is the answer sa anakang violet. So, para mabuo lang speed kang dalawang colors, so for red, among gyapon nga formula, speed is equals to C over N. So, para sa red is 3 times 10 raised to 8 meter per second divide sa 1.72, it equals to 1.74 times 10 raised to positive 8 meter per second. So, amor niya ang speed of light kang red. So, speed of light kang violet is 3 times 10 raised to 8 meter per second divide sa 1.84, it equals to 1.63 times 10 raised to 8 meter per second. So, last is polarization. So, polarization occurs when light is allowed to oscillate in one direction only. Light from sources such as light globe and the sun are unpolarized. They have light waves which oscillate in every direction or plane. So, ang polarized light is allow lang tana to move or swing back and forth in one direction only. So, ang unpolarized light is example na kaya is like sun, like globe, amukara. So, for the example, if the beam of polarized light has 1/5 of its initial intensity after passing an analyzer, what is the angle between the axis and the beam's initial amplitude? So, ang given is, initial intensity is 1/5. So, ang ginasagap natin is theta. So, ang 1/5 nga, i-divide mo tana. So, may mga 0.2. So, using Mallows law. So, ano nga niiran? So, initial of intensity is equal to 0.2 intensity of polarized cosine raised to theta. So, cosine 2 theta is equals to 0.2. Cosine theta is equals to square root of 0.2 is equals to 0.447. Thus, theta is equal to cosine raised to negative 1 is raised to negative 1, 0.447 is equals to 63.45 degree. So, ang answer is 63.45 degree. So, amularakan, continuation kang ana ni Carl.
So, the next topic is geometric optics. Explain image formation as an application for reflection, refraction, and facial approximation. First is mirror. A mirror is a surface that reflects almost all incident light. So, my two types of mirror. First is plane mirror and spherical mirror. First is plane mirror. A plane mirror is simply a mirror with a flat surface. Image produced by plane mirrors have a number of properties, including first is the image produced is upright. Second is the image is the same size as the object. Third is the image is the same distance from the mirror as the object appears to be. Example, the image distance is equal to the image. The image distance is equal to the object distance. So number 4 is the image is a virtual image as opposed to a real image because the light rays do not actually pass through the image. This also implies that an image could not be focused on a screen placed at the location where the image is. Second is spherical mirror. Spherical mirror is a section of a sphere with reflected surface and produce an image that has different size from the mirror, from the object. Ang spherical mirror, ang ma-produce ng image is bukatan na perya sa may object. So may two types of spherical mirrors. First is concave mirror. The reflected surface curves inward when parallel incidence rays are reflected. The two will intersect at the focus. This focus is at the front of the mirror. Second is convex. The reflection surface curves outward. When parallel incidence rays are reflected, the extension of the reflected rays seem to intersect at the focus. The focus is at the back of the mirror. The spherical aberration is a defect that occurs when the outer parts of mirror do not bring light rays into a similar focus as that of the central part. So, ginatawag na spherical aberration kung ang mirror is do not bring light rays into a similar focus. Refraction of light in a plane and spherical surfaces. First is refraction of light as plane surfaces. So, when a ray of light strikes the plane surfaces, for instance, a rectangular glass slab, it bends as soon as it enters the other medium. So, once ka mag-strike ang ray of light sa plane surfaces, so naga-bend na. After refracting from its original path, the light ray travels straight and comes out of the glass slabs. As soon as it comes out, the The ray again refracts and bends. This phenomenon in which light's bending occurs is known as the refraction of light. So, refraction of light at spherical surfaces. When two spherical lenses come in contact with each other face to face, it forms a spherical lens shape. Spherical lenses have two types. First is concave lenses and convex lenses. When the ray of light passes through the concave lens, it forms a virtual, erect, and diminished image. Concave lens. A concave or converging lens is shaped so that all light rays will enter it parallel to its optical axis intersects at a single point on the optical axis on the opposite sides of the lens. Concave lens. A concave or diverging lens is shaped so that all rays that enter it parallel to its optical axis diverge. Concave lens is nagadiverge na. Concave and convex lenses, image formation. So, convex lenses. When an object is placed at infinity, the real image is formed at the focus. The size of the image is highly diminished and point size. So, sa convex lenses, once an object is sa infinity, so ang ma-form na nga image is gamay lang kana compare sa object. When an object is placed beyond the center of curvature, the real image is formed between the center of curvature and focus. The image size will not be the same as the object. It will be diminished in size. So, kung ang object is placed natin sa center of curvature, the image form. So, ang ma-image ka form is as between sa my center of curvature and focus. So, ang size ko object is bukat man tana the same sa my object. When the object is at the center of curvature, the real image is formed at the other center of curvature. The size of the image is the same as compared to that of the object. So, para standard size kang object once nga ma-place ang object is sa center of curvature. Next is, when an object is placed in between the center of curvature and the focus, the real image is formed behind the center of curvature. So, if ang object is sa may between the center of curvature and the focus, so, ang image nga form is behind the center of curvature. So, ang image is mas bahol compared sa object. When an object is placed at the focus, the real image is formed at infinity. The size of the image is much larger than of the object. Once na place ang object sa infinity, once ang object is ma-place sa focus, the real image is formed sa may infinity. So the size of the image is much larger than of the object. When an object is placed between the focus and optical center of curvature, a virtual image is formed. The size of the image is larger than of the object. Next is concave lenses. When an object is placed at infinity, a virtual image is formed at the focus. The size of the image is highly diminished and point size. Bukat ang parehas kang object kang image kang size. When an object is placed at a finite distance from the lens, a virtual image is formed between the optical center and the focus of the convex lens. So the size of the image is smaller than of the object. So mas gamay ang image nga ma-form compare sa object. And that is partial approximation. The partial approximation is a simplification used in geometric optics to analyze light rays passing through optical systems like lenses and mirror. It assumed that light rays travel at a small angles relative to the optical axis, allowing for a simpler mathematical calculation. A partial approximation is ginagamit sa geometric optics na mag-analyze kang light rays passing through optical system like lenses and mirror. It assumed that light rays travel at small angles relative to the optical axis, allowing for simpler mathematical calculations. That's all. Thank you.